All right, welcome back to the second to last week of the quarter and the semester. This week, what we're going to do is we are going to look at another way to do division of polynomials. So last week we did division of polynomials by a monomial, and we did division of polynomials by a binomial. And with a binomial, we had to use long division. And so there's another method that we can use instead of long division that some of you might find a little bit easier. Maybe not, but it's worth a shot to have a couple of different ways we can do this. And the method is called synthetic division. So we're going to use synthetic division to divide some polynomials by binomials. And what I'm going to do is I'm going to start with the second example first. Even though it's more complex than the first one, I think it's going to do a better job of showing you how to do this. So I'm going to zoom in on the second one, and hopefully we can figure out how to do this. All right, so the first thing we want to do is, when we're doing synthetic division, is identify coefficients on all of the terms here. So, or in the case of the 18, it's a constant. So we have a coefficient there, it's a 1, right? And then we've got a negative 13, we've got a 40, and we've got an 18. All right, so the 1's not there, but we can add it there, and maybe I should add it with like red so we can really see it. All right, so there's a 1 there. And what we're going to do is we're going to take those coefficients and we're just going to write them all down. So I'm going to write down a 1, negative 13, 40, and then the constant, that's 18. And I'm going to draw a large upside down division symbol. So this is kind of similar to the long division symbol, but it's upside down now and it's quite a bit larger. Okay, and then what I'm going to do is I'm going to use the binomial to come up with a number that's going to be right there. And the way I'm going to find that number is I'm going to take my binomial x minus 7 and I'm going to set it equal to 0 and just solve for x now. So all I have to do is add 7 to both sides and I get x is equal to 7. So I'm going to put a 7 inside that red highlighted area. Okay, so these are the two main steps that we have to do to set up a problem for synthetic division. We have to identify the coefficients and the constant, and then we have to find the number that we're going to be using on the outside of the division symbol to do the synthetic division. Okay, so once we have that, we can start the process. And here's how the process works. Number one, we're always going to bring down the first number. Okay, so that 1 is there. We're just going to bring it down and we're going to put it right there. And then what we're going to do is we're going to take the 7 that's on the outside here. We're going to multiply it by that 1 and we're going to write a 7 right there. Okay, and then what we're going to do is we're going to add that 7 to the negative 13. So we have negative 13 plus 7 is negative 6. Okay, and then we're just going to keep repeating that process. So now I'm going to take the 7 and I'm going to multiply it by the negative 6. I get negative 42. And I'm going to add that negative 42 to the 40. So it's a negative number. Another way to think about it is it's just 40 minus 42. So it's going to be negative 2. And then I'm going to repeat the process again. I'm going to take the 7, multiply it by the negative 2. I get negative 14. So I'm going to be adding negative 14. And 18 plus negative 14 is just 18 minus 14, or 4. Okay, and now this is where I think this problem is going to do a better job of showing you how this works compared to the first one. So now these numbers have some meaning, and what they mean is the first column, so this 1 right here, is the coefficient on an x term of some sort. And the way we find the x term that it is the coefficient on is we look at the fact that we have an x to the third power in the polynomial that we're dividing, and we have an x in the binomial that we're dividing by. And the difference between x to the third and just x, or x to the 1, is 2, right? So this is an x squared term. So that means if we just look at the x to the third and the x, this is an x squared term, right? And then what happens is each term from there on just reduces the exponent by 1. So the first one is an x squared, the second one is an x to the 1, right? But we don't typically write that one, so I'm not going to write it. And then this would be the x to the 0 term, but we know x to the 0 is just 1, so it won't have an x, right? It would just have a 1, so we can just kind of ignore that 0 term, so I'm going to get rid of that and leave it just like that. Okay, and then what I'm going to do from here is I'm going to take the numbers that I have, and those numbers end up becoming coefficients on the variables that are there. And you'll see what's going to happen here. So the 1, so we end up with 1x squared. And then it's -6, so it becomes -6x. And then we have the -2 there. There's no x, so it just becomes -2. And then this is the unique one. The last number here is always the remainder. All right, so this is our remainder. And just like last week, what we do with remainders is we take the remainder and we add it to our answer. But then we have to divide it by what we're dividing by. And this is where I want you to be really careful, because some of you might put the 7 underneath it, but we don't want to put the 7 underneath it, because what we're actually dividing by in this problem is the binomial x minus 7. So we have to put the binomial here. So our answer is x squared minus 6x minus 2 plus 4 over x minus 7. Okay, let's look at another one. So let's go back over here and look at this one that only has 3 terms in the polynomial that we're dividing. So we're going to do the same process again. So we're going to look at those coefficients. So here there's a 1 there, right? There's a -7, and then that constant is -11. So I can go ahead and add that 1 in there just so we can have it. So what we have is we have a 1, a -7, and a -11. I'm going to draw my upside down division symbol, and then I need to find a number that goes right there. I think I used red. I probably ought to use red again just to be consistent. I'm going to find a number that goes right there, and I'm going to find that by setting the binomial that I'm dividing by equal to 0. So this is m minus 8 equals 0. Add 8 to both sides. So m equals 8. Okay, so we have m equals 8, so I'm going to put an 8 there. And so I'm all set up now to do my synthetic division. And so what I need to do, the first step is always bring that first term down, so it's a 1 down here. And then 8 times 1 is 8, so I'm going to be adding 8 to the -7. And when I do that, it equals 1. So then I have 8 times 1 again, same thing, right? 8, so I'm going to be adding 8 to the -11, so this becomes a -3. Okay, so in this case, and this is why I felt like this one wasn't the best example to show you the original process. If we look at the polynomial that we're dividing, it has an m squared term in it. We look at the binomial, it has an m term in it, and the difference there is just m to the 1, or just m, right? So we're going to have this first term, the first number, the first 1 is an m term. The second number is our constant, and the third number is our remainder. Okay, so what we're going to end up with is we're going to end up with 1m plus 1. In this case, minus 3, because it's a -3, divided by m minus 8. Okay, and if you are at all doubting yourself, what you can really easily do with these is just use long division to be able to do this division. So let's do this one with long division and see if we get the same answer. So we have m minus 8, and then we have m squared minus 7m minus 11. Okay, so if we look at that m and the m squared, we know we're going to put an m here. M times m is m squared. That's what we want, right? M times negative 8 is negative 8m. But remember, we're subtracting that thing, so we're really adding that 8m there. So the m squareds cancel each other out, but we're adding that 8m, so it becomes 1m minus 11. So we bring that negative 11 down. And then we have m and 1m. Well, that's just a 1, so we're going to have plus 1. You can see it's kind of working out. We're getting the right things. So 1 times m is 1m. 1 times negative 8 is negative 8. But remember, we're subtracting that. So when we subtract that, we're actually adding the 8. So we end up with negative 3. And that's what we had before, right? So we got the same answer. So we have m plus 1 minus 3, and then we're divided by m minus 8. Okay, now you might be saying, hey, wait a minute, it's not the same. It doesn't have a 1 in front of the m. Well, yeah, it does. We just didn't write it there, right? So you can always add that 1 to it, but we don't necessarily need it there. So I just wrote it there because during the synthetic division, we end up with those 1s, and some of you might wonder, well, where'd the 1 go? Well, that's why I included it. All right, there we go. So you have an assignment that has, I believe, only 4 of these to do. So if you have questions, you're going to want to make sure you let me know.